when you account for the rise of sea level and the isostatic subsidence of the sea floor, it's not at all implausible that you had a large island complex in the mid-Atlantic.
In a world where everyone believed the same story about how Egypt's Great Pyramids were built for many years, Randall Carlson comes forward as someone who disagrees with that idea. Carlson has spent his whole life trying to figure out what really happened in the past, like solving a big puzzle about what terrifying discoveries has Carlson found that make us rethink what we thought we knew about the pyramids? Join us in this adventure as we explore how Randall Carlson solved Egypt's pyramid mystery and why scientists are scared.
When the world went cold again during the Younger Dryas, the water, the meltwater flowing from the glaciers into the oceans, declined if it didn't stop altogether.
The Younger Dryas period, skillfully named after the resilient Dryas octopetala flower, which bravely blossomed in the frigid environments of Europe during this time, beckons us to delve deeper into Earth's enigmatic past. Spanning roughly from 12,800 to 11,500 years ago, these years represent a pivotal juncture from the waning days of the historic period to the developing stages of the recent years, heralding significant ecological and climatic shifts. As the world emerged from the grip of the last ice age, a period of relative warmth commenced. Yet around 12,800 years ago, a remarkable event happened. A sudden, dramatic downturn in temperature shattered the prevailing warmth. This cooling, estimated to be between 2 to 6 degrees Celsius, gripped the planet in an icy embrace, halting the warming trend with astonishing swiftness. But what caused this abrupt climate reversal? Scientists speculate that a series of cataclysmic events may have triggered this climatic reversal phase. One leading theory posits that the collapse of massive ice dams, such as those holding back glacial lakes in North America, unleashed torrents of frigid fresh water into the North Atlantic Ocean. This influx disrupted oceanic currents, particularly the Gulf Stream, which plays a crucial role in regulating global climate. Moreover, evidence suggests that a cosmic collision, possibly with a comet or asteroid, may have contributed to the Younger Dryas cooling. This impact would have lofted vast quantities of dust and waste into the atmosphere, blocking sunlight and further exacerbating the cooling effect. In the wake of this climatic upheaval, ecosystems underwent profound transformations. Forests retreated, giving way to expanses of snow forest, while glaciers re-advanced in some regions. These changes posed formidable challenges to early human populations, compelling them to adapt their lifestyles and survival strategies to the harsh, unforgiving conditions. During the Younger Dryas period, which lasted from about 12,900 to 11,700 years ago, the Earth experienced a dramatic cooling event following the end of the last ice age. This abrupt climatic shift occurred after a long period of warming known as the Bolling-Allarod interstadial. The cause of this sudden cooling has been a subject of intense scientific investigation. One of the proposed explanations for the onset of the Younger Dryas is the freshwater influx hypothesis. It suggests that the release of large volumes of freshwater from melting ice sheets, particularly from the Laurentide ice sheet covering much of North America, disrupted the oceanic circulation patterns, particularly the Atlantic Meridional Overturning Circulation AMOC. This disruption could have triggered the rapid cooling observed during the Younger Dryas. Additionally, evidence from various parts of the world indicates that during the Younger Dryas, there were shifts in vegetation patterns and animal populations. For example, in North America, there was a decline in the population of megafauna such as mammoths and mastodons, possibly due to changes in their habitats and food sources. Furthermore, recent research has highlighted the potential role of extraterrestrial impacts in amplifying the effects of the Younger Dryas cooling. The falling star impact hypothesis believes that one or more falling star fragments struck the Earth or exploded in the atmosphere, releasing immense energy and triggering widespread wildfires. These wildfires, fueled by the ignition of flammable gases released during the impacts, could have contributed significantly to the cooling and environmental changes observed during the Dryas. The impact hypothesis gains support from the discovery of nanodiamonds and other impact-related agents in sediment layers dating to the Dryas boundary. These findings suggest a sudden influx of extraterrestrial material around that time, further bolstering the idea of catastrophic cosmic impacts influencing Earth's climate and ecosystems during this period. In summary, the Younger Dryas was a pivotal period in Earth's history, marked by rapid climate change and environmental upheaval. While the exact mechanisms driving these changes remain the subject of ongoing research and debate, the interplay of factors such as freshwater influx, ocean circulation dynamics, and potential extraterrestrial impacts underscores the complexity of Earth's climatic systems and their sensitivity to external influences. Scientists have made a captivating discovery that sheds light on an ancient global catastrophe. A fascinating discovery of carbon-rich installments has captivated scientists, revealing a tale of ancient upheaval buried within the Earth's sedimentary layers. These installments, unearthed at numerous younger sites, hold within them clues to a dramatic event that reshaped our planet's history. Supporters of the hypothesis linking these installments to a catastrophic event point to an array of compelling evidence. Microscopic metal fragments and nanodiamonds, typically forged under conditions of extreme pressure and high-velocity impacts, provide intriguing insights into the event's intensity. Moreover, elevated levels of rare elements like iridium and platinum found within these installments further bolster the notion of a significant cosmic or terrestrial upheaval. The striking black color of these installments hints at their fiery origins, suggesting widespread wildfires of immense proportions. Such fire may have raged across vast expanses of land, leaving behind layers of charcoal and soot in the geological records, and evidence of the ferocity of the ancient conflagration. Yet, amidst the allure of this hypothesis, challenges and controversies abound. Foremost among them is the conspicuous absence of a definitive impact crater, the hallmark of celestial collisions. Some proponents argue that the celestial body responsible for the event may have disintegrated upon entry into Earth's atmosphere, or perhaps struck a region covered by ice.
There are people who've been working on these things for decades now, basically in secret,
obscuring any discernible crater formation. Intriguingly, alternative explanations for the climatic shift emerge from the depths of scientific inquiry. Some researchers assume changes in ocean circulation patterns as a potential driver of environmental change during this period. Meanwhile, others speculate on heightened volcanic activity as a plausible catalyst for the observed alterations in Earth's climate. As scientists delve deeper into the mysteries concealed within these mysterious installments, each layer of discovery unveils new complexities and challenges, beckoning humanity to unravel the secrets of our planet's troubled past. The ongoing discourse surrounding the possibility of a falling impact persists, despite not achieving unanimous acceptance within the scientific community. The theory proposing a younger Dryas impact, approximately 12,800 years ago, is a subject that not only ignites curiosity, but also challenges conventional understanding. This hypothesis, rich in geological intricacies and climatic disruptions, offers a captivating narrative. Central to this hypothesis lies a plethora of geological evidence, each piece contributing to the intriguing puzzle. For instance, alongside the discovery of nanodiamonds, scientists have also unearthed evidence of shock diamonds. These microscopic crystals, exhibiting telltale signs of extreme pressure, are found scattered within sediment layers across continents, further bolstering the notion of a cataclysmic event. Moreover, the Younger Dryas impact hypothesis presents an array of microspherules, minute spherical particles that have been linked to extraterrestrial impacts of volcanic eruptions. These microspherules, discovered in abundance within sediment layers corresponding to the Younger Dryas period, not only hint at the magnitude of the event, but also offer insights into its potential origins. Furthermore, the presence of elevated levels of iridium, a rare element on Earth but prevalent in meteorites, adds another layer of intrigue to the hypothesis. Coupled with the identification of magnetic grains containing iridium, this evidence strengthens the case for an extraterrestrial impact of substantial scale. Scientists use state-of-the-art tools to examine sediment layers dating back to the Younger Dryas era, and what they discovered is absolutely astonishing. Researchers have uncovered traces of platinum and platinum group metals within sediment layers associated with the Younger Dryas period. These findings, alongside the presence of soot and carbon-rich layers, provide compelling evidence of widespread burning. Additionally, analyses of sediment cores from various regions have revealed anomalous spikes in temperature and evidence of abrupt environmental changes, aligning with the proposed timeline of the Younger Dryas impact. Some 12,900 years ago, there was a time when Earth trembled beneath the weight of a celestial visitor. Embedded within the Earth's crust lie remnants of this cosmic encounter, in the form of iron oxide minerals established within a glassy matrix. A proof of the cataclysmic power unleashed upon impact, these traces serve as silent witnesses to a moment when the heavens kiss the earth in fiery passion. But the saga doesn't end there. It merely unfolds its next chapter along the eastern seaboard of the United States, where the landscape bears scars of a celestial dance. Enter the Carolina Bays, a brief hole etched into the land, their origins a subject of real debate among scholars. Could these enigmatic depressions be the vestiges of secondary impacts, born from the fragmentation of a falling star hurtling through the cosmos? As the plot thickens, envision the aftermath of this cosmic drama, a symphony of darkness organized by the celestial interloper. As the falling star's fiery embrace met Earth's atmosphere, it unleashed a chaos of dust, soot, and particulate matter, painting the skies in shades of ebony. Sunlight, once the lifeblood of the planet, found itself thwarted by this celestial veil, casting the world into a perpetual twilight. In the wake of this cosmic curtain call, temperatures declined with revenge, sending a chill that gripped the planet in its icy embrace. Climate models and the frozen archives of Greenland and Antarctica bear witness to this chilling tale, documenting a sharp decline in temperatures that coincides seamlessly with the proposed impact. Yet the chill was most keenly felt in the northern reaches, where temperatures dropped by a staggering 3 to 11 degrees Celsius, plunging once thriving landscapes into a frozen slumber. But the falling star mischief extended beyond the surface, delving into the depths of the ocean's embrace. Major ocean currents, such as the Atlantic Southern Overturning Circulation, found themselves disrupted by the falling star's celestial touch, further aggravating the chill that gripped the North Atlantic in its frigid collection. Thus, the saga of these hexagonal diamonds in Carolina Bays weaves a fabric of cosmic intrigue, inviting us to peer beyond the veil of time and space into a world where celestial forces shape the very fabric of existence. Amidst the transition from the Pleistocene epoch to the Holocene era, a captivating saga happened across the landscapes of North America, coinciding with the Younger Dryas period. This year witnessed the demise of numerous iconic megafauna, leaving behind a void in the ecological fabric of the continent. Among the casualties were the majestic woolly mammoths, towering mastodons, formidable saber-toothed cats, lumbering giant ground sloths, and even the once roaming North American camel and horse. However, the vanishing act of these huge creatures was not a uniform affair. Instead, it manifested as a patchwork quilt of extinction events, with some regions bearing the brunt more severely than others. North America, in particular, suffered a disproportionate toll, as evidenced by the dearth of fossil records and the haunting echoes of once thriving ecosystems. What adds a layer of intrigue to this ancient narrative is the synchronicity between these extinctions and the Younger Dryas period. This previous era, marked by climatic fluctuations and ecological disturbances, has become the focal point of intense scientific scrutiny. Advocates of the Younger Dryas impact hypothesis posit a tantalizing link between a cosmic interloper, a falling star hurtling through the celestial expanse, and the devastating events that happened on Earth's surface. The proponents of this theory paint a vivid picture of cascading ecological disruptions triggered by the falling star impact. Wildfires ravaged the landscape, leaving charred remnants in their wake. Climate oscillations plunged the continent into an icy embrace, disrupting established patterns of life. Crucially, disturbances rippled through the intricate web of the food chain, disrupting the delicate balance that sustained these magnificent beasts. In the face of such unprecedented challenges, the resilience of North America's megafauna was put to the ultimate test. Yet it appears that nature's relentless march outpaced their adaptive capabilities, consigning these titans to the records of history. There are so many complexities surrounding the extinction events of the past. Alongside the overkill hypothesis and natural climatic changes, there are other intriguing theories that add depth to our understanding. For instance, the overkill hypothesis posits that early humans, equipped with advanced hunting technologies, might have played a pivotal role in driving certain species to extinction. The idea is that these ancient hunters, with their increasing population and sophisticated tools, could have exerted immense pressure on the environment and its inhabitants. Moreover, natural climatic changes during the transition from the Pleistocene to the Holocene years were marked by significant shifts in temperature and precipitation patterns. These environmental fluctuations could have created conditions unsuitable for the survival of many species, contributing to their demise. Additionally, recent studies have shed light on the potential role of extraterrestrial impacts, such as meteorite strikes, in triggering or exacerbating these extinction events. The Younger Dryas impact hypothesis, in particular, suggests that a comet or meteorite impact around 12,800 years ago might have unleashed catastrophic environmental changes, further destabilizing ecosystems already under pressure from human activities and natural climatic shifts. Examining fossil records provides crucial insights into the scale and scope of these extinction events. The sudden appearance of a multitude of fossil remains within a relatively narrow time frame underscores the abruptness of these losses, leaving a profound mark on Earth's biodiversity. As the scientific community continues to explore these competing theories, each discovery adds another layer to the intricate puzzle of Earth's past. Understanding the dynamics behind these extinction events not only enriches our knowledge of the planet's history, but also holds valuable lessons for conservation efforts and the preservation of modern biodiversity. Concurrently, as the Clovis culture flourished, another significant event was happening: the Younger Dryas period. The Younger Dryas, a climatic episode lasting approximately 1,300 years, is a period hidden in mystery and intrigue. Researchers have long puzzled over the abrupt onset of colder and drier conditions during this era. What's more intriguing is the apparent correlation between the waning influence of the Clovis culture and the emergence of the Younger Dryas. It's as if the Earth itself orchestrated a dramatic shift, altering the course of human history. Imagine the impact on these ancient peoples as they grappled with the upheaval brought about by this environmental transformation. The once abundant resources upon which they relied suddenly dwindled, forcing them to adapt swiftly or face extinction. The lush landscapes they once traversed now became barren and unforgiving, testing their resilience in ways they could scarcely have imagined. Archaeological evidence serves as a silent witness to this monumental shift. The tools of survival, once finely crafted and adapted to the rhythms of the land, underwent a metamorphosis reflective of the changing environment. Human ingenuity, always a driving force, rose to the occasion, fashioning new tools and adopting novel strategies to secure sustenance in this altered world. Moreover, this period of upheaval did not merely mark the decline of one culture, but heralded the rise of a multitude of diverse societies. As the cloak of the Clovis culture receded, it unveiled a fabric of regional variations and adaptations, each a proof of humanity's resilience and capacity for innovation in the face of adversity. Carlson's insights further deepen our understanding of these climatic upheavals. By highlighting the Younger Dryas as a pivotal moment in Earth's history, he challenges conventional wisdom, urging us to reconsider the stability of our planet's climate systems. Drawing parallels with other climatic events such as the Bowling-Ailerod warming period, he invites us to peer into the records of the past, where rapid shifts in climate left an indelible mark on the landscape and its inhabitants. In essence, the story of the Clovis culture in the Younger Dryas is not merely a tale of the past, but a window into the intricate dance between humanity and nature, where resilience, adaptation, and innovation intertwine to shape the course of history. For centuries, scientists have strived to unlock the secrets of Earth's climate. In the pursuit of unraveling Earth's climatic mysteries, scientists have meticulously scrutinized historical events, aiming to decode the intricate dance between our planet and the cosmos. Among such inquisitive minds, Carlson's hypothesis stands out as a beacon of curiosity, proposing a tantalizing notion that celestial bodies, like falling stars and asteroids, may have wielded a profound influence on Earth's narrative. Imagine a time when a fiery streak across the sky signaled not just wonder, but potentially cataclysmic change. Carlson speculates that such cosmic visitors might have triggered a series of dramatic events, from plunging the planet into icy grips of an ice age to jolting it with abrupt climatic shifts. These impacts, he suggests, could have even cast a shadow of extinction over various species, shaping the very fabric of life on Earth. Here, Carlson and his group of impact hypothesis proponents point to a singular event, a cosmic collision, as the prime mover behind an abrupt climate upheaval. Their argument gains strength from the robust evidence gleaned from geological archives in ancient ice cores. Imagine scientists carefully extracting ice cores from the remote expanses of Greenland and Antarctica, like ancient time capsules preserving Earth's climatic history. Within these frozen records, Carlson discerns distinct layers, relating to chapters in a troubled saga. These layers, he contends, bear witness to rapid fluctuations in temperature and atmospheric composition, hinting at the commotion created by celestial visitors. But the intrigue doesn't end there. Beyond the ice cores lie other geological clues, each a piece in the cosmic puzzle. Sediment layers enriched with iridium, a rare metal often associated with extraterrestrial impacts, serve as silent witnesses to cosmic encounters. Elements linked to celestial bodies, scattered amidst terrestrial waste, further corroborate the cosmic collision theory, painting a vivid portrait of Earth's troubled past. In the quest to understand Earth's climatic fabric, Carlson's hypothesis beckons us to gaze beyond the confines of our planet, to ponder the cosmic interplay that has shaped our world. The idea put forward by the impact hypothesis suggests that the discovery of certain types of diamonds in sediment layers, along with signs of wildfires, supports the theory of a massive cosmic event around 12.9 thousand years ago. This event, according to Carlson's theory, challenges the widely accepted timeline of human history. He suggests that there may have been advanced human civilizations long before what we traditionally consider the beginning of history, potentially even predating the last ice age that ended roughly 11,700 years ago. This challenges the common belief that civilizations like the Sumerians and ancient Egyptians, which emerged around 6,000 years ago, were the earliest advanced societies. He argues that these prehistoric civilizations weren't just technologically advanced, but also possessed deep spiritual insight and wisdom. He speculates that their technological prowess may have included advanced architecture, astronomy, and other sciences beyond what we typically attribute to ancient cultures. To support his theory, he points to the intricate design and construction of ancient structures like the pyramids of Egypt and Stonehenge, as well as various megalithic sites found worldwide. He suggests that the precision in construction, along with alignments with astronomical events such as solstices and equinoxes, indicates a sophisticated understanding of astronomy. This challenges the mainstream archaeological view, which often underestimates the knowledge and capabilities of ancient civilizations. In essence, his theory proposes a fascinating alternative narrative of human history, suggesting that ancient peoples may have been far more advanced and knowledgeable than previously thought. Across the globe, marvel at the enigmatic arrangement of Stonehenge.
Some of the stones are even heavier. So how could you have moved these into place? How could you have moved them from Wales, where the blue stones, the spotted dolerite, came from within Stonehenge?
Gracefully synchronized with the changing solstices, marking the passage of time in ancient splendor. These wonders, as Randall Carlson proposes, offer more than mere architectural marvels. They hold clues to the profound mysteries of ancient civilizations. Carlson's visionary perspective dares to suggest that the downfall of these advanced societies might have been organized by catastrophic events of cosmic proportions, falling star impacts, or relentless natural disasters that engulfed lands and civilizations alike. In the wake of such cataclysms, vast populations may have vanished, leaving behind a void of knowledge and technological abilities. Yet, amidst the ruins and remnants, he sees whispers of the past, echoes of lost wisdom encoded within tradition, sacred scriptures, and cryptic symbols scattered across diverse cultures. In his eyes, these ancient tales and enigmatic patterns serve as cryptic chronicles, veiling symbolic references to real events in the education of bygone years. However, his theories challenge the conventional narrative of mainstream archaeology, daring to venture beyond the confines of traditional cradles of civilization. He assumes the existence of experienced societies flourishing tens of millennia ago, long before the recognized bastions of human advancement emerged in Mesopotamia, Egypt, the Indus Valley, and China. Intriguingly, this urges a reconsideration of history's fabric, reminding us of the sweeping transformations that once reshaped our planetary canvas. Amidst the relentless pursuit of artifacts and tangible evidence, he beckons us to contemplate the magnitude of Earth's ancient metamorphosis, a narrative often overlooked in the quest for archaeological validation. In essence, Randall Carlson's theories weave a captivating narrative, bridging the chasm between the known and the unknown, inviting us to reimagine the annals of human antiquity with renewed curiosity and wonder. This intriguing notion not only challenges, but reshapes the conventional narrative of human development, suggesting that our ancestors may have achieved remarkable feats long before previously assumed. Delving deeper into the evidence presented by Carlson, we find ourselves captivated by the inspiring tombstone, structures scattered across the globe. Consider the pyramids of Giza, monumental marvels that have stood the test of time. Beyond their sheer size and beauty, these pyramids exhibit an astonishing precision in their alignment with the stars of Orion's belt. The intricate construction techniques employed in their assembly continue to baffle modern scholars, sparking endless speculation about the advanced knowledge possessed by their architects. Similarly, journey to the ancient plains of Salisbury and behold the enigmatic wonder of Stonehenge. This iconic monument, composed of massive standing stones, serves as a celestial observatory, with its alignments carefully marking the movements of the sun and stars. The significance of its structures hints at a profound understanding of celestial mechanics among its builders. Venturing within the pyramids of Giza reveals even more tantalizing mysteries. Deep within this ancient construction lie shafts that pierce through the pyramid's core, emerging on the exterior and aligning with specific celestial bodies. These celestial alignments not only demonstrate a sophisticated grasp of astronomy, but also hint at a spiritual or ritualistic significance attributed to the stars by ancient cultures. Indeed, the existence of such structures challenges our preconceived notions of ancient societies as primitive or technologically limited. Instead, they paint a picture of civilizations with a profound understanding of the cosmos, pushing the boundaries of human achievement far beyond what we previously imagined. Carlson's exploration into the engineering and architectural achievements of ancient civilizations unveils a plethora of fascinating details. Among the exciting details unveiled are the innovative methods employed by these builders to transport huge stones. From the use of sledges and rollers to ingenious ramp systems, each technique showcases a blend of practicality and ingenuity. Moreover, recent archaeological findings suggest that some ancient structures may have been assembled using complex mathematical principles, indicating a sophisticated understanding of geometry and spatial relationships. The shifting landscapes of millennia have obscured much of their original settings, yet geological clues offer tantalizing insights. For instance, evidence of ancient quarries and quarrying techniques provide valuable clues about the origins of these monumental stones, shedding light on the logistical challenges faced by ancient builders. Moreover, his hypothesis regarding a potential large island complex in the mid-Atlantic Ocean is supported by geological evidence of submerged land masses and underwater formations. These submerged features hint at a lost world beneath the waves, prompting speculation about the existence of advanced civilizations predating conventional historical timelines. The Great Pyramid of Giza remains a proof of the unparalleled skill and precision of ancient craftsmen. Recent studies utilizing advanced laser scanning technology have revealed minute discrepancies in the pyramid's dimensions, suggesting a level of precision previously unrecognized. Additionally, the discovery of hidden chambers and intricate internal passages within the pyramid continues to fuel speculation about its true purpose and significance. Across continents, megalithic structures bear witness to the ingenuity and ambition of ancient societies. From the enigmatic stone circles of Europe, such as Stonehenge, to the majestic pyramids of Egypt and the intricate temples of Mesoamerica, each site offers a glimpse into the rich fabric of human history. By unraveling the mysteries of these ancient wonders, scholars like Carlson invite us to reimagine the story of our past and reconsider the capabilities of our ancestors. Carlson's insights into the ancient world reveal astonishing parallels in construction methods and astronomical alignments across diverse cultures, spanning continents and eras. These striking similarities hint at a potential shared or globally disseminated repository of knowledge among ancient civilizations. Imagine the wonder-inspiring sight of the Great Pyramids of Giza, perfectly aligned with the cardinal points of the compass, or the intricate stone carvings of the Mayan temples, carefully designed to mark celestial events with uncanny precision. His suggests that these feats of architectural mastery may not have been isolated achievements, but rather manifestations of a collective understanding that transcended geographical boundaries and cultural differences. Moreover, he delves into the intriguing concept of a lost advanced knowledge, positing that cataclysmic events may have precipitated its disappearance from the records of history. He often refers to the Younger Dryas impact hypothesis, proposing that a comet collision or series of impacts around 12,800 years ago triggered drastic climatic shifts, marking the abrupt end of the last ice age. Imagine a scenario where massive fragments hurtle towards Earth, causing widespread devastation. The resulting chain reaction of events includes catastrophic flooding, abrupt changes in temperature, and the collapse of ecosystems. Entire civilizations, once thriving and prosperous, are plunged into chaos and oblivion as their cities are engulfed by rising seas or buried beneath layers of remains. The implications of his research extend far beyond mere academic curiosity, offering profound insights into the resilience of ancient societies and the fragility of human civilization in the face of cosmic forces. It's a narrative that evokes both wonder and terror, reminding us of our interconnectedness with the cosmos and the enduring mysteries that lie buried beneath the sands of time. Which one of these mysteries that Randall Carlson solved in Egypt's pyramid and made scientists scared do you find intriguing? Share your thoughts and answers with us in the comments below. And if you enjoyed watching this video, make sure you give a thumbs up and subscribe to the channel.